everyone. My name is Ariel Siminet.
My name is Mohammed Abdurrahman.
And today we're going to basically give you a comprehensive overview of what we've done in our civil design. Our civil design name is Advanced Energy Communities, and this is our organization.
Start at the top by Senior Brower, who's our principal investigator. Also, Alex, who's a graduate student, is technically our team lead, and we function under him, the energy modeling team. We got the commissioning team. We got theoretical review, which also do the documentation pretty much. We have the estimators, purchasing managers, and financials over there.
So the product definition, basically why are we doing this? So for a little background, California has passed multiple laws in which they want to increase the percentage of renewables in terms of the production and the utility for residents. So right now we are 27% of our energy is renewable based, and we want to be 50% in 2030. Now, one way to accelerate this is through the deployment of what we call AECs, Advanced Energy Communities. Through commissioning and energy modeling, we can reduce the demand for a specific area, and then we can implement renewable energies to make it sustainable. So we have a lot of sponsors, as you can see.
So basically our goal is to generate a generic advanced energy community by implementing renewable energy generation technologies and also implementing techniques which lower energy demand. And we plan to put this all in a compile this all in a final report and file it to the companies we're working with to be used in future development throughout the state of California.
Exactly. So basically, what have we done so far, right? The work done, because even though we have to speak about the problems we face and how we have found solutions, we have thought about what we actually did, right? So what we did is we worked on, basically it's a case study, we worked on an area called Oakview in Huntington Beach. And what we did is, in that community, we split it in 3 departmts: industrial, commercial, and residential. And for each sector, we found about 10 buildings that represent that area pretty well. And we modeled each of these 10 buildings through a program named Open Studio. The program can give us a lot of information in terms of the energy that's leaked, how much it consumes, what kind of renewables you could apply to that specific building in that area. And through there we can get an overall sense of what kind of energy profile we have and what type of renewable energy we can implement in that neighborhood.
So here we have the residential buildings. This is an example of an energy model used. That's an example of an IR survey, which is considered part of the commissioning work. And the estimators used energy intensity values to calculate demand before retrofit using the square footage and the demand after retrofit. And this would be incorporating the energy demand limiting techniques like smart grid and whatnot, and also our supply from the generation of the renewable source like PV would be 77 megawatts. So as you can see, the supply is greater than demand, which far exceeds the zero net energy requirement, which we are aiming for.
So this was for residential. We also did the same for industrial. So as you can see, this is the actual picture from maps. And then here you have the modeling through the Open Studio program that we had. So before the retrofit, we have 516 megawatts, and after the retrofit, we have 361. And through our program, we rendered that we can actually produce 407 megawatts through solar. So it's once again zero, net zero.
Here we have the commercial. This is our most acquainted building, the Oakview Community Center, which is used as a Boys and Girls Club. That's a gym, and basically those are offices over there and a classroom. And we use this building as our model for commissioning. And as you can see, the demand before is 41, the demand after is a lot less, and our supply is greater than our demand after, so it far exceeds the zero net energy demand. So it's actually generating technology rather than just consuming. So generating energy. Sorry.
So always keep in mind that this is just one model, but we have up to 10 or 15 depending on what sector.
Yeah.
Now this is obviously our progress and timeline. Last time we came, most of it was about 70% done. This is just to show you that we had different departments working on different things. Obviously you can't just dive into energy modeling without knowing what you're doing, so we have people working in the economic standpoint, how much this would cost, that has to go into our report in the spring. Our commissioning, which Mohamed was part of, he had to go measure the actual bills, etc., how much energy was used. We had literature review and thermodynamics review. That was me and my team that did that. So it's different domains that we all had to work together. And then this is basically our timeline. This is almost the same as we had last quarter. Now we've just finished all the last minute modeling that we had to do, and we're wrapping up everything right now in our report that will be submitted to the NREL. Funny enough that our grad student is also, his thesis is actually on renewable energy, so he's actually using this at the same time, second parallel.
So coming into any project, you think one thing going out of it, you definitely learn a lot. So here I'm going to talk about what we learned from this project. So our big takeaways from this project is that most problems are not technical. I thought it was going to be difficult to deal with all the engineering aspects, but actually not. There's a lot of bureaucracy that was involved in getting data from these utilities that sponsor us, but it would take 6 months just to get some simple utility data about a building or whatnot. And also, NREL was supposed to give us a program called Urban Op to use for energy modeling, which was supposed to be given to us in March. They promised, and they did not deliver till now. So this is one of the what's it called, lessons learned, as well as people think that implementation of renewable energy is really easy, and in 10 years people just say, oh, we could go 100% renewable. Actually, it's a lot more complex. Renewable energy is really intermittent and variable, and hence is less dense than conventional energy generation technologies which use coal and natural gas. Therefore, if we want to delve into the future and make 100%, energy storage is going to be a necessity, whether it be power to gas, battery, whatever you want, depending on the geographic position and what is more feasible. Also, this is for all teams, I bet you guys know this. People get the job done, not positions. Just because you're a team manager does not mean you're going to get the job done. It's your work and your individual diligence which will get the job done.
Now, another thing that we had to look back is basically what went right and what went wrong. One thing that we did well is the commissioning process. We had to basically use 2 surveys to benchmark what we were doing, because not only were we doing an energy modeling of that area, we also had to compare to something that was actually sort of accepted in the industry. So we used 2 of the surveys. One is called REX, and that one is for all the nation. It's based for residential only. And the other one, CCEUS, is for California, and it's for commercial and residential. So once we had done all the energy modeling, we could compare that to the survey and see how far we were from it. There were certain ratios that we had to fall inside. There was ratio that we had to be in a sort of range, and we fell on it, meaning that our modeling was actually pretty good. The same thing happened with the energy square foot. We used the OSC's California ISO data. It's basically kind of like a survey, but it's using the Southern California gas companies' data. So it's the same thing, but just a different source. And the thing that we could have done better, once again, is bureaucracy. That took a long time. Sometimes we wanted to have specific bills, or we wanted to have energy consumption for a certain area, and it was very hard to get that because of privacy. So we had to keep a sort of balance between the people's privacy and at the same time getting that data. So that was one problem. And the other thing was a certain company that promised us certain software that didn't go through at the right time, so we had to do a different software or call other people and basically replace what should have been given.
So basically, we would request that data earlier and try to find plan Bs and plan Cs before we set on the plan. So here I'm going to talk about the ethical issues we faced and also the standards that we use in our designs and whatnot. So big ethical issue, since we're dealing with a low-income community, Oakview is a low-income community. It's a square mile with over 10,000 people, and that's really the population is really dense there, basically. And by retrofitting renewable technology and advanced energy technology, the property value is going to increase. And since we're dealing with a low-income community, they probably won't be able to afford this, and hence they are going to move, just like in the Bay Area, just like in Central LA and whatnot. So we are in this process is called gentrification. We're working with the city, community, the property owners, the landowners, the nonprofits, all to ensure that the property values will not increase and gentrification not happen. And also, my work is to do commissioning, so I have to go to a lot of buildings within the community, and I do have to request access like usually a week to a month in advance before I go there. So it's easy for me just to step on the lawn and just do what I have to do, but I do have to like get access before I go to make sure that we did do that. So the main standard that we're using is Title 24, which is basically a compilation of many standards like ASHRAE 69.1, which deals with air ventilation for zero net energy homes, and ASHRAE 189, which deal with the envelope and exterior of zero net energy home. These are all compiled in Title 24. And the objective of this title is to reduce California's energy consumption. And these outline all the benchmarks which we should stay under to maintain that zero net energy value that we are seeking to achieve. Also, as you've seen before in the energy models, we are trying to push the limit and generate energy rather than just consume and ensure it's just zero net energy. So there's actually a challenge called the Living Building Challenge, which is way more rigorous than LEED and BREEAM energy standards. And this means it's actually like a living building and produces energy rather than just consumes.
So now in terms of contemporary issues and lifelong learnings, obviously our goal is basically to mitigate climate change. We know it's really important for us to not only we have to deploy renewable energies, we also have to think about the demand side of things. Often people look about the supply, but we have to look at the actual cost. So if we drop the demand, then we have less energy that has to be produced. And that's why we looked not only at the supply, but also the demand. That's why we went through retrofitting, retrofitting instead of just looking at the supply and actually just putting renewable energies. Because if you look at the demand, it doesn't cost that much. You can actually lower the price of how much energy you have to produce for renewables. So it's kind of like a win-win. It's a win-win perspective.
And here we have, like we said, Urban Up. That's a little picture of the program. So basically, it's a program with Open Studio deals with buildings. With Urban Up, you could make buildings, put them into a grid, a neighborhood, and you could basically build from the ground up, all the way from your building, all the way to your community. You can have a whole energy, compiled energy model right there. And basically, we are working with NREL currently to improve, to develop code for this program, and hopefully it'll be functional by next year. I think they said fall quarter next year, October, yeah. To get the energy use intensity surveys, we would request them far earlier, and now we know the process, so it's going to be a lot easier to deal with these utilities to get the data, as well as get data from the utilities like SoCalGas. We are going to pressure utilities to give us more localized data, such as residential loads and whatnot, rather than a whole zip code. Because they're just giving us aggregate data based on zip codes, but they do not represent the dynamics of the loads at localized locations like certain buildings or residences.
So now this is basically our results, so to say. It's a Sankey diagram. Like I said, on the left you have the supply that you can change. Now the energy demand is split in 3 departments that we had: industrial, residential, and commercial. We thought that the project would have been bigger, so you could have seen it, but basically what we try to do is we try to reduce the demands that the energy supplied will also reduce. And also another thing is to reduce the energy loss, because there's always a certain percentage, around 6-7% California, that is lost just for the grid. So through this Sankey diagram, you can exactly see, for example, in industrial, you have 7.5 gigawatts of energy that's required in that area for the industrial buildings. Out of that, you know that there's a certain part of it, 70% that goes from the grid, and the other 30% comes from natural gas. So 70% of it is electrical. The other 30% actually comes from coal. So it means that LA, for example, produces energy from coal, and that 30% goes to the industrial part of our area. And then from there, we can get the aggregate of the energy that is producing greenhouse gases. And then from there, we can know also the clean energy percentage of the energy that we produced, how much of it is actually clean energy. Now, from the ratio of the energy that does produce greenhouse gases, we have certain ratios that enable us to find exactly how much greenhouse gases are produced from that area. So we can know how much carbon dioxide production, our emission of carbon dioxide or methane or nitrous oxide. So we can have basically a GHG footprint for our community. And the good thing is that through the way that we actually did our report, it's a report that's scalable. It's sort of like a blueprint for any community in California. So you just have to change a few parameters, but it's applicable in many different communities in the state of California.
Basically, that report is like an instruction manual too. Like, oh, you want to make your advanced energy community, here are the steps to take. This is what we did, and here are the programs we use. So do this, do that, do this, and you'll have your advanced energy community.
Yes, sir.
Thank you.